And welcome in, my party people. Today we are working on distance, rate, and time. Specifically, we are going to look at one of the bigger headaches when it comes to distance, rate, time. And I'm going to show you that even if this is your first class with me or you're brand new to studying for this test, I'm going to show you a very common type of question that you can absolutely get right as long as you understand the little details instead of trying to memorize questions and hope for the best. So let's make the most of this here. Number one, the first thing we're really going to get into is refreshing on the formula. I think we all know that there's a formula to distance, rate, time, and it's going to serve us very well to just take a moment, understand that formula and how it works, and then we'll move right forward here to reviewing common situations and how to approach them. Like, hey, if we have two cars that are driving separately, how long does it take for them to get 150 miles apart? Or if we have two trains headed towards each other, how long does it take for them to collide? So those are the types of questions that we'll be looking at today. And number three, once we build that comfort, we are absolutely going to practice under a timer. We're going to make sure that we're, again, not memorizing, but indeed truly understanding the topic to apply the ideas. So let's go ahead and get into it, everybody. Let's go ahead and start off with the formula. So the formula here is distance equals rate times time. Everybody go ahead and take a second to write that down with me. I'm going to write it down right here. Your formula is, again, distance. I'm going to spell it all out for us. Distance equals rate times time. Right there, my party people. There we go. So we have three components, as you can see. Distance, rate, and time. Now, I think we can all recognize a time unit like seconds, minutes, hours, days. And I also think that for the most of us here, we can absolutely recognize every single type of distance, like inches, feet, yards, miles, kilometers, things like that. But one of the things that a lot of folks confuse with time and confuse with distance is going to be rate. So for example, one of the more common mistakes that people make is misinterpreting something like 40 miles per hour. Let me write it all out for us. Something like 40 miles per hour. A lot of folks will misinterpret this, seeing hour, and think that this is time, or see 40 miles and think that this is distance. So quick question, everybody. What's the difference between 40 miles, 40 hours, and 40 miles per hour completely? What is the difference that we see with what's written on the screen? Absolutely. It is that word there, per. That is the key. That's the secret recipe there. When you see the word per, we're not talking about cats. We are talking about two units being joined together. We have miles in 1 hour. So what we mean when we say 40 miles per hour, we're not just saying 40 miles. We're not saying hours. We're saying in every hour that we're dealing with here, we'll travel 40 miles. Again, for each hour that we go, we travel 40 miles. So everybody, if we're actually traveling for 2 hours, what am I supposed to do with this 40 miles per hour to see how far I go in 2 hours? What operation am I supposed to use? Absolutely, we're supposed to multiply. Because remember, to get the distance, to get how far you are going, we are going to multiply our rate. Let me go ahead and take this purple highlighter here. We're going to take our rate and multiply it by time, which in my little example that I gave you would be 2 hours. So help me out, everybody. What's 40 multiplied by 2 going to give us? What's 40 miles per hour multiplied by 2 hours? Yeah, that's going to give us 80. So in this little miniature example that I'm giving you, don't worry, we're going to have plenty of examples to go through. But in this little miniature example, 40 miles per hour going for 2 hours, we multiply those together, and that'll give us 80 miles. So everybody, before I continue, does it make general sense before I continue that anytime you want to find distance, again, specifically when you want to find distance, We want to multiply the rate and time together. Does that make sense, everyone? Yes or no before I continue? Sweet. And I'm glad that that makes general sense. And again, we'll get plenty of practice in the coming moments here. So let's flip the script. Let's reverse this thing. Because as we all hopefully know, whether literally or intrinsically here, as most of us know, whenever we're doing something going forward, we know that there's a backwards element. And that's why I really made sure to include this right here. Everybody think about it. Out of the three of these, distance, rate, and time, which one of these is already alone? Which of these is already alone? The distance, the rate, or the time? Correct. It is the distance. It's already alone by itself. So to get distance, it's really just about doing whatever's over here. Rate times time. But we have to deal with some issues sometimes. And that's going to be looking for the rate or looking for the time. Everybody, now let me ask this question. Is the rate or time, or either one of these already by themselves? Are these already by themselves, or are they cluttered? Yeah, there's a little bit of clutter here. There's clutter. If you're trying to find the rate, well, the time is in the way. If you're looking for time, the rate is in the way. Has anybody here do we remember hearing working backwards to solve equations? Yeah, and that's the idea that we're going to be piggybacking off of. Everybody, what operation do we see right here? What operation do we see right there? Yeah, that's multiplication all day. Everybody, if we have to work backwards, again, don't even worry if you understand this all right now or not. You're good. I got your back. Don't worry. Just answer this question here. If I'm trying to do the opposite of multiply, just remind me, everybody, you know me, I'm not good at math. What's the opposite of multiplication? Absolutely, that's going to be division. So be ready to use multiplication, but also be ready in this lesson today. Be ready to divide. So again, regardless of whether you are totally on board or a little confused, does that part make sense? Just be ready to multiply and divide in today's class. Sweet. Sounds good. So we're going to go through about 5 examples of just very straight up, I'm going to give you the rate and time, find the distance. I'll give you the distance and the rate, find the time, working backwards, and give you distance and time, find the rate. I'm going to help us get our feet wet, get used to the formula, and then we'll dial up the fun. We'll dial up the fun and look at those situations where we have multiple objects moving towards each other and away from each other at the same time. So let's go ahead here and take a look at our first example. Again, the formula that you have to worry about, distance equals rate times time. Hopefully we've had enough time to write that down. Now let's get into this first example. So it says here, a cyclist rides at a steady speed of 12 miles an hour, yada, yada, yada. I'll be real with you. The first thing that you should always do in word problems is not read everything from start to finish. That's the easiest way to trigger some anxiety. The first thing you want to do, my friends, is read the question. You can see my students, if you're here live, you see half of my students yelling at me because I committed the cardinal sin. So we always want to start with reading the question first. Right here, how far does the cyclist travel in 5 hours? All right, so this question is for those of us who are sitting in the back, a little anxious, not exactly confident. Let me ask you this, everybody. We're dealing with 3 things in this class: distances, rates, and times. Can y'all tell me, if we are asked, how far does a cyclist go? How far does anything go? Which one of those 3 does it sound like we're talking about? Does it sound like we're talking about distance, a rate, or a time here? Yeah, absolutely. All day, distance is correct. Absolutely. So that's what we're looking for. Again, how far does the cyclist travel? That's telling me all day that I'm looking for distance. How far is it from here to the nearest Chipotle? How far is it from here to mom's house, right? That is distance. If you're hungry, I'm sorry. Now, number 2, in this same red highlight, in this same question, we are given a specific value, and that's going to be right here, in 5 hours. My party people, what kind of a unit are we going to designate that as? Specifically because of the unit hours, what is that going to be? Correct. That's going to be a time. That's correct. That is a time unit. If we were dealing with something like, let's say, miles per hour, that's a distance and a time put together. That is a rate. So let's write down what we have here to make sure that we have all of our ducks in a row before we try this out. So let me change this coloring here to green. 5 hours. That is a time unit right there. And then I see up here, let me highlight purple, or let me just use blue for more contrast. We have a steady speed that this cyclist is riding at, and it says 12 miles per hour. Everyone, the number itself doesn't matter. I want us to really never focus on the number. I want us to really focus on what the word means, or the number means. So it's 12 miles per hour. It's not just miles, and it is not just hours. It is miles per hour. Pop quiz, everybody. What's the word that gives it away? What's the word that gives away that we're dealing with a rate? Excellent. Now we're getting it. Yes, the word per. The word per is what gives rates away. Now, let's go ahead and say they shorthanded it. Let's say they said 12 mph, not miles per hour. Let's say they said mph. Okay, everybody. If they used mph, where else could we look in this problem? Because, yeah, I know a lot of us know that mph means miles per hour, so I'm happy y'all get that. But let's say we ignored that for a moment. Where else in that sentence, in the blue highlights that I made, where else does it give away that you're dealing with a rate? Yeah, the phrase right there, steady speed. Everyone, for the purpose of today's class, speed and rate are the same thing. Speed equals rate. Per equals rate. That's going to be a nice clue there to write at the top of your paper and really reference that throughout every problem. So, everyone, at this point, are we good with this example, knowing that we're looking for distance, the how far, we have time, 5 hours, and we have a rate, 12 miles per hour? Are we good with the information that we've pulled so far? Sweet. So once you have your information pulled, all we have to do now is, and pay attention, I know it sounds easy with this problem, but we really have to commit to placing the numbers in the right places. Yeah, exactly, Jaslyn, our formula. Let's go ahead and build out our formula so I can show you what I mean. Remember that distance equals rate times time. Everybody, what are we plugging in for D? Which one of these numbers are we plugging in for D? Correct, nothing. I'm just trying to trick y'all. There we go, keeping you on your toes. There is nothing we're plugging in for D. It is unknown still. So I'll just keep it as D. You can write X for it. You can do whatever you want. Just don't fill in 5 or 12. Neither of those belong in there. Next up, tell me, what are we going to plug in for R? Correct, we're going to plug in 12 because our rate is 12 miles per hour. So we'll plug that in, nice and easy. And then lastly, we have ourselves the time. What time period are we plugging in? Correct, that'll be 5 hours, and that'll make it 12 times 5. So with that, everyone, our final answer is going to be achieved. The distance is going to be achieved by multiplying the rate and time together. 12 times 5 is going to be what? And that'll be 60. Correct. D equals 60 miles, because again, distance is listed as that first unit, miles, and then the time is listed as that second unit, hours. So thankfully the time unit lined up, and we know that the distance unit lines up to the front of rate, the miles. So there we go. Was that painful or painless before we continue to the second example? So everyone, in the next example here, first things first, what do we do? Read the question. That's right. That's the first thing we want to do. And remember, for those of us that are here for the first time, I'm not saying to read the problem. I'm saying to read the question sentence right there. What is the speed of the train? Okay, everybody, let's talk about keywords and phrases here. It's not like that first one where it said, how far did we travel? Here it says, what is the speed of the train? Everybody, what's the key word that I'm going to circle in this red highlight? What's the specific keyword that I should circle? Correct, it's going to be speed. What did I just say, everybody? Speed is interchangeable with rate. Exactly. So can we all agree before I continue that the goal of this problem is to find rate? Excellent. There we are. So that's step one. Remember, you never want to start playing a game for which you don't know the rules. It's never fun. Always learn the rules first. My goal here is to achieve the rate. Perfect. Step two, let's work with the information that we have. It says a train travels at a constant speed for 3 hours. Everybody, let's read that again. A train travels at a constant speed for 3 hours. Did they give us the rate here? Like literally, explicitly, did they give us a number for the rate here? Correct, they did not. They did not. They just say that the train travels at some speed that we're not going to tell you. And then the word for 3 hours reveals that the time frame is 3 hours. So we have to be careful here. We don't want to make assumptions seeing a key word like speed and assuming that the next number you see is that representation. It takes a little bit of candor, staying calm, cool, and collected to really make these, adjustments and point out these units. Next up, it says after we talk about traveling for 3 hours, it covers 180 just miles, not miles per hour, just miles. Everyone, what does this 180 represent? Yeah, that's going to be distance. It's just miles. So that is just distance. So I'll write that down over here. Distance equals 180 miles, and we're good. Everyone, are we ready to plug in what we know so we can try to find that rate? Are we ready? Heck yeah, right on. Let's go ahead and get that done then. So here we go. We're going to fill in our formula. Distance equals rate times time. And let's go ahead and do this, quickly. Like somebody who is going to be doing this, pretty quickly is going to want to do this fast. So let's plug in our numbers. I'll leave D there. I'll put 180 times 3. There's the time. Okay, cool. Is this good, everybody? Are we ready to multiply? Man, you guys are really trying to disagree with me today. What's the problem? Yeah, we're actually supposed to be dividing. But why is that the case? Yeah, because I don't have the rate, but I accidentally plugged in for the rate. Look at what I just did there. I don't have a rate. I'm looking for the rate, but I accidentally filled that in. Has anybody here ever done that? Especially when it comes to formulas like this, where you plug in everything on one side and then you get what you get by itself on the other. Yeah, most of us make that mistake, so I just wanted to do that to bring attention to that potential mistake. What's actually supposed to happen is we're going to be filling in where we have those variables. The D, the distance, it's 180. So do this faithfully. D is what I'm going to be replacing with 180. Again, you have to work with what you see. Next, for R, I'm just going to leave it as R because that is what I'm looking for. Leave it as is. And then for T, I'll plug in the 3 hours. Notice that I'm plugging everything in as if I'm just literally replacing the number or the letters with the numbers. Still multiplication on the right side. But now that we take a step back, I realize, hey, I'm trying to get this rate by itself. There's a multiplication of 3 in my way. Everybody, if you're solving an equation and there's a number being multiplied by 3, like there's a variable being multiplied by 3, how do I get rid of that 3? Yeah, we have to do the opposite. We have to work backwards. We're going to divide by 3 on both sides. And I'm going to say it again, on both sides to solve the equation properly. So once we do that, check this out. I'm going to divide by 3 on the right side and on the left, knowing that on the right side, if I do multiplication and division of the same number, it cancels out. And so now all we have to remember or do is 180 divided by 3. And what is that going to be, my friends? Yeah, that'll be 60. Now, can you tell me 60 what? 60 what? What is that going to be? Yeah, that's going to be miles per hour, because remember, your rate is your distance per time. Miles per hour. So that's what the units will be. 60 miles per hour. Nice and easy. And there we are. There's your first problem where we've worked backwards. So my friends, let me know. Are we feeling good about problems where we're working straight forward, just multiplying to get the distance, and knowing that we're going to have to work backwards when we're not given the rate or the time? There we go. Again, if you're looking for the distance, you're working straight forward. If you're looking for the rate or the time, you're working backwards. So let's go ahead and try this next one out. First things first, everybody. Tell me, what is it that we're looking for in this problem? I'll give you 5 seconds to type it into the chat box while I slowly highlight the question sentence. And 3, 2, 1. Yes, we're looking for time. We're looking for time in this problem here. Specifically, it says, here's our proof. How long does the trip take? Think about it. Think about other situations where you might have heard that phrase. How long does it take to bake a cake? How long does it take to get to work? Right? How long does something take? We're talking about time. So how long does the trip take? We will say confidently that we are looking for time in this problem. So with that said, everybody, are we good to proceed knowing that we're looking for time? Perfect. Now let's go ahead and take a look at the information that we're given. Let's take a look at the information here. So a car moves at a constant speed of 50 miles per hour. Everybody hit me in the chat box. What's the word I'm looking for? 50 miles per hour represents, with that keyword per, it represents rate. Exactly. So again, speed and the word per, both of those give away that 50 miles per hour is a rate. So 50 miles per hour right there. And then it says if the driver covers 200 miles, how long does the trip take? And so everyone, covering 200 miles, that is what? Correct. That is distance. So we'll highlight that as well. Covering 200 miles, that is distance. So now all we must do, everyone, is just keep a lookout for yourself. When you plug into the distance, rate, time formula, we just have to make sure we plug everything into the right place. So for the distance, 200, that's what we're plugging in right here, 200. Then for the rate, we see that we had 50 miles per hour. Just make sure you plug everything in correctly. 50 right there. The time that we're looking for, I'll just leave it as T for time. Just like that. Help me out, everybody. What operation do we need to solve this problem? Multiplication or division in this case? Yeah, that is going to be division here. I need to get rid of the 50. I'm trying to get the T by itself. There's a 50 in the way. It's just hugging it with multiplication, and we want to tell that 50 to get away. So with that, we'll divide the 50 out. But as always, make sure that whatever you do to one side, you do to the other. So we'll divide by 50 over here as well. On the right side, it's going to cancel. Anything you multiply and divide at the same time, again, will cancel. So 200 divided by 50, it's going to be 4. 4 times 50, will be 200. So we have ourselves 4 hours as our unit of time. And again, I knew it was hours because we have 50 miles per hour. So hour gives away what that time unit is. Hours. And there we have it. That's their second problem where we're working backwards. Is anybody here feeling slightly more confident in terms of what I said during the note-taking process with going forward and working backwards? Excellent. Good. I'm glad that we're feeling good. So we have 2 more example questions to go before we kick it up a notch to the multi-object distance, rate, and time problems. So let's keep having as much fun as we can now before you feel like, getting a cardboard cut out of me and punching a hole through it. So let's go ahead and move it over here to this next example where I'll give you a chance to try it out first. Let's give this next one a shot. Let's get that timer out of the way here. And here we go. So everybody quickly tell me, when we highlight the question sentence, those sentences that start off with who, what, when, where, how many, which of the following, that's really what we care about. So how far has the boat traveled? What does that mean we're looking for here, folks? Yeah, that's going to be distance. How far does something travel? There it is. We're looking for distance. Next up, let's understand the information that we're given. In the same sentence, it says after 2 hours. Everybody hit me. 2 hours is what? Yeah, that's time. Absolutely. So we're given time. That's 2 hours. And then we see that in the first sentence, it says a boat moves down a river at 15 miles per hour. Everybody, that's a rate for sure. You're all correct. But what is the key word that gives it away? Correct, the word per. The word per gives it away all day. The word per connects miles and hours together, making it a singular unit as miles per hour. Again, saying for every hour, we travel 15 miles. So I'll write that down over here as our rate, 15 mph or miles per hour, and now we're ready to solve this problem. I'll set up my formula, distance equals rate times time. Distance is what we're looking for, so I'll keep that as is. I'll plug in the rate and the time respectively as 15 for the rate and 2 for the time. So now we have 15 multiplied by 2, and that's going to give us our answer. If we need to work on it on the side over here, no problem at all. 15 multiplied by 2, we'll have 5 times 2, giving us 10. Carry that 1. 1 times 2 is 2. Carry that 1, it gives us 3. So our distance traveled by this boat is going to be 30 miles. And there we are, everybody. Boom, I'll zoom on out right there. But there we go for the fourth example of today. Feeling good about it, Sam? Right on, man. Let's go. So remember, everybody, with every problem that you do, no matter what, we have to be able to justify what we do. We need to be able to back up what we do, give reasons for what we do. It's because even if you're correct, and I hope that this is good advice for everybody here, even if you're correct, if you cannot explain with confidence what you did, how you did it, and why you did it, then it's going to be very hard to justify being confident about test day. That's your goal, everyone. If you can explain what you do, you're in a good position. Everybody, does that make sense before we continue to the next example? So let's give this next problem a shot. And as you might imagine, this caused a little bit of stress because it's not inherently, obvious to someone who's trying to refresh on the mathematics. It's not obvious to these folks, exactly how to navigate this. But there is one thing I told you from the very get-go, always. Everybody, what is the first thing we always do to approach a word problem? Correct. We are going to start by reading the question. So no matter how confused you were, you should still be able to identify what it is that you're looking for. Watch this. I'm going to read the question. If they each run for 3 hours, that's not the question. The question starts here. What is the distance between them? So everybody, even if we were nervous, even if we got up and said, no, coach just betrayed me, what is the actual question here? What are we looking for? Yeah, exactly. We're looking for distance right here. Does everybody agree? It says, what is the distance between them? Can we all agree that we're looking for distance no matter how confusing this looks? Good. So let's write that down. We are looking for the distance between them. Okay. And I'll just say the distance between these two cars, or these two runners, between A and B. That's all I'm looking for. The distance between A and B. So everybody, let's look here. It says that we have two runners and they start from the same point and run in opposite directions. Okay, so here's what I'm going to do. When in doubt, I'm going to draw it out. So let's go ahead and draw a little circle here. And let's say that both of our runners start from that spot. Now we have runner A, and runner A runs at 6 miles an hour. Runner B runs at 4 miles an hour. And it says that they each run for 3 hours. Okay, Now, this is a lot of mumbo jumbo here, right? Because not only do I not have one rate, I have two, 4 miles an hour and 6 miles an hour. What am I supposed to do with all that info? Here's what you can do. You might notice that it says runner A runs at 6 miles an hour, and they each run for 3 hours. So everybody, if I am going to be talking about runner A going this way at 6 miles an hour, how long does it take this runner to complete his run? For how many hours is this runner running? Ariane, correct. Yeah, that's 3 hours, exactly. So we have 6 miles an hour, 3 hours. Everybody, how do I compute distance again? How do I calculate distance? Yeah, my distance is going to be rate times time, right? Distance equals rate times time. Let me write that right up there, because everybody, if I go ahead, let me actually just write this a little bit higher there. If I'm thinking about what I have here, I'm going to be doing what times what? That's going to be 6 times 3. Exactly. Everybody, 6 times 3 is going to give us what? 18. Correct. So our distance here is 18 miles going this direction, going to the left. Okay, cool. Now let's zoom on out and let's talk about runner B. Let's use purple for this. Let's say runner B starts from the same spot and goes to the right. Okay, everybody. Now let's talk about runner B. Runner B's information is listed right here. Runner B runs at 4 miles an hour, and again, still runs for 3 hours. So let's write that down. We have 4 miles an hour going for 3 hours. Let's go ahead and use our distance, rate, time formula. Distance equals rate times time. Everybody, what two numbers am I going to be multiplying together? That's going to be 4 times 3. Sounds good. And so 4 times 3 gives us what, everyone? Yeah, that's going to be 12 miles. Sounds good. So even though we just sat here and did all these calculations, the question is, what do we do now? What do we do now? Am I supposed to add these, subtract these, multiply these, divide these? What are we supposed to do? Well, here's what we're supposed to do. Everyone, think about it like this. If I take this same example and I make it even easier, smaller numbers, smaller lines, let's go ahead and make it look like this. Let's say we start right here, and let's say that runner A goes 1, 2, 3 steps to the right, and let's say runner B goes 1, 2 steps to the right. So runner A goes 3 steps to the left, I may have said to the right, but runner A goes 3 steps to the left, runner B goes 2 steps to the right. What do you think the total distance between this point here and this point here is? Yeah, the distance between them is 5. And here's how we know. It's not going to be 1, it's going to be 5. Because if you have runner A going to the left, runner B going to the right, well, the distance between them is the total distance. You're adding them up because A goes to the left, B goes to the right. If you were going to subtract, that means that there's overlap like this, but there's not. If it was like this, you would be saying, yeah, there's only 1 step between them. But that's not what's happening. That's not what's happening at all. What's happening is this is where runner B ends up, and this is where runner A ends up. So what we have to do here, my friends, we have to add, because from here to here is going to be 1, 2, 3, and then the additional 2, 4, 5. That's why we add the distances in this case. Add the distances in this particular case. Does that make a little more sense for anybody out there? Actually visually seeing it in this way? Excellent. And even if it doesn't, don't worry. We'll have plenty of examples and we have some nice notes coming up as well. But let's zoom on out just slightly to see everything again. And now let's take a look at the example at hand. Runner A went 18 miles this way. Runner B went 12 miles that way. So if we want to go all the way from here to all the way over here, we have got to add it together. We'll add the 18 miles from this with the 12 miles from this so we can get the entire distance. which is going to be 18 plus 12. And that, everyone, is going to give us what? Correct. That will give us 30 miles. That is how far apart they are. Specifically, everybody, specifically because they go in opposite directions. Let me highlight this right here. Specifically because they went in opposite directions, we add those distances together. Specifically because they went in opposite directions. All right. So I'm so happy to see in the chat box that we're having a lot of those light bulb moments. I'm hoping that we're having those same light bulb moments for anybody who's watching the recording at home. But there we are. The key word here is, again, opposite directions. That's what gives away that we'll be adding. So now allow me to show you your main notes for what we're doing today. Here we go. So if two objects are moving toward or away from each other, we are going to add their rates to find the rate of approach or separation. So here's what I mean, everybody. I think we all know what away from each other looks like, but I'm still going to show it. Let me go ahead and show you here in blue. Let me go over here. Exactly what we just did. If we're going in opposite directions, we are going to add this plus this to get the total distance together. If we are going toward each other, let me go ahead and show you this right here. Toward each other, it falls under the same rule. We will still add the distances together. And let me prove this to you. Let me prove it to you nice and easy to help you ease your mind. Let me say we have one person here and another person here. Everybody, let's say that these folks are, let's say, 10 units apart. Let's say they are 10 units apart from the beginning. Well, guess what? Let's say this person moves 2 steps towards the other person, and the second person moves 1 step towards the first person. Everybody, how much closer did these 2 runners or people get if the first runner took 2 steps towards the runner and the other runner took 1 step towards the first? Yeah, that's going to be 3. Exactly. The distance that they are apart now is 7. So those of you saying 7, you're still correct. But they are moving toward each other 3 steps at a time because it's 1, 2, and 3, making it now 7 spaces apart. So again, if they're moving away from each other or toward each other, we are still going to add those rates and add those distances to find out how far apart they are. My party people, before I continue to the other situation, does that first situation make sense? We're talking about the rate at which these objects are moving together. And if they're moving in opposite directions or toward each other, we will add. All right. Now here's part 2. This one is the one that most people find a little bit of challenge with until we get to the examples to really show what's going on. So let me see if I can entertain you enough with this example here. So first, let me go through the notes, and don't worry, I'll give you time to write this down as well. But if 2 objects are moving in the same direction, let me highlight that perfectly for us. If 2 objects are moving in the same direction, what we are going to do is we are going to subtract the slower rate from the faster rate, because this is going to help us find the rate at which they are moving apart. Let me show you this. Let me zoom on in here. Don't worry. Like I said, I'll zoom out and let you write your notes. But let's go ahead and say we have runner A again and runner B again. Now let's say runner A, let me just draw the line for both of them. Let me actually draw the line right here. Now let's say that runner A in blue takes, let's go ahead and say 5 steps. 1, 2, 3, 4, 5. Now let's say that runner B is going in the same direction, but runner B takes, let's say, 3 steps. 1, 2, 3. So this is where runner B ends up, and this is where runner A ends up. Everybody, how far apart are runner A and B now? How far apart are they? One of them went 5, another one went 3. Okay, a lot of people here are saying 2. Okay, why 2? Is it 2 because I told you to subtract, or is it 2 for an actual reason? Yeah, look, the real reason here, the reason that we are going to subtract, everyone, Not just that we see physically that, yeah, sure, there's 1, 2 spaces between them. I know we can see that with our eyes, but I want you to understand the why. And the reason why is this: because they are traveling in the same direction, these first 3 steps, 1, 2, and 3, they both covered that ground. They both covered the same exact distance. Perfectly said, Chanel. That's the next word I'm going to say. They overlap. And so because they overlap, after the first step, they're both still together. After the second step, they're both still together. After the third step, they are both at the same point. It's only the first runner that takes the extra 2 steps that makes that gap. But everybody, what's that C word when one thing does the same work as the other in the opposite way? What is that C word? What did they do to each other? Yes, they canceled each other out. They canceled each other out, allowing us to, again, just ignore what they traveled together so we can only focus on the gap. That's why we subtract if they're going in the same direction. Does that make sense for us, everybody? Are we ready to perhaps try a problem out with subtraction? Sounds good. Let's give it a shot here. So let me take a look here. Let me zoom on down. Perfect. All right, everybody. Let's go ahead and take a look at this example here. So everybody, excuse me. Actually, you're absolutely right. Let me go ahead and bring it back. Let me be fair to everybody. I promised you. Let me go ahead and put this right here and give yourself a moment to write this down before we move forward. So first things first, everybody, as we come back here and start this problem off, tell me, what's the first thing we do? Read that question, right? Exactly. So here it says, in red, how many more miles has car B traveled than car A? Now, there's already, in this question sentence, there's already a huge hint, everyone. Already a huge hint. What's the phrase in the red highlight that we see here? What's the phrase in this red highlight that will help us get a huge hint at what we're doing? Yeah, how many more miles? Exactly. How many more miles has car B traveled than car A? Everybody, when we think about it, let's go ahead and say we're talking about finances. Let's say Coach Anderson has $10 in his wallet. Let's say Kevin has 15. When we ask the question, how many more dollars does Kevin have than Coach Anderson? What operation are we doing there? What operation? If we say Kevin has 15 and I got 10, how many more does Kevin have? That's subtraction, right? That is subtraction. So that's already going to be a hint. That's already a hint at what we might need to do. How many more miles has car B traveled? Right there. So let's just go ahead and write that down here. We're looking for the distance between car B and car A, the gap between them, how many more miles one travels than the other. So let me write that down. The distance is what we're looking for. Now let's take a moment here to write down the other pieces of information. And then I'm going to show you a second way to do this problem that will save you a lot of time. So here we go. Let's go ahead and read here. It says 2 cars depart from the same location at the same time, both traveling east. Okay, sounds good. So let's say that we have both cars traveling east, one like that, and then another like this, just to go ahead and express what we see. It says car A moves at 40 miles an hour and car B moves at 60 miles an hour. Okay, let me just move this a little bit over here to make it make a little more sense. Now let's say that we have car A, 40 miles an hour, car B, 60 miles an hour. Okay, so that's that right there. Car A, 40, car B, 60. Everyone, how much time do these cars spend traveling? Yeah, that's going to be 4 hours. That's each of them. Again, they're both driving for 4 hours. So let me go ahead and just show the time here. Times 4 hours, times 4 hours. Because again, everybody, the way that we get distance is going to be multiplying the rate and the time. So let me zoom in over here and really wrap this up. And let me expose my horrible handwriting. Wow. So there we go. Hours right there. And let's give it a go. Everyone, what's the distance that car B travels? 60 times 4 gives us what? Yeah, 240. That's going to be 240 miles. Let me go ahead and highlight car B in green. And so that'll be 240 miles. All of this right here. All right, everybody. Now let's take a look at car A. We have 40 miles per hour times 4 hours. What distance is that going to be? Yeah, that's going to be 160. Absolutely. Absolutely. So let's go ahead and use purple for this one just to get some color going there. And so when we multiply, that'll give us 160 miles. All right, great. Now that we have that, everybody, how do we calculate the gap? How do we calculate this gap? That's going to be subtraction. Absolutely. Because to find out how many more miles car B travels than car A, that's subtraction. They go in the same direction. All of this here, we subtract it, we cancel it. We only care about that. So 240 minus 160, the gap is going to be 80 miles. There's our gap. 80 miles is our gap. And there we are. So everybody, before I continue and show you the much faster way of doing this, does the initial idea, does the principle of the matter make sense? That if they're going in the same direction, we are going to subtract so that we can get that gap. Let me know if that makes sense before I show you this faster method. All right, sounds good. Now let's check out again what I wholeheartedly, professionally believe is the faster method. Here we go. Watch this. We have two rates. Let me write these down. We have our first rate being 40 miles an hour and the second rate being 60 miles an hour. So I'm going to highlight both of them. I'm just going to use purple for both right there. So we have rate A, 40 miles an hour, rate B, 60 miles an hour. And then the time that we spent traveling, everybody, how much time was that? Yeah, it's still going to be 4 hours. It's right there. 4 hours, very clearly listed. Now, here's the problem. The problem is most people are going to look at this and say, if I want to use my distance rate time formula, I have a problem because I have two rates. But you just received permission to combine those rates. Right here it says both traveling east. Again, traveling in the same direction. What operation did we say we would use if they're traveling in the same direction? Correct, we will subtract because we are looking at the gap. Yes, we are looking at the gap between these objects, these cars specifically. So watch this, everybody. If I go ahead and subtract 60 minus 40, my actual rate is going to be what? Yeah, my actual rate is going to be 20 miles per hour. That's how far apart they're moving per hour. Every hour, think about it. If car A goes for 1 hour, that's 40 miles. 60 miles for car B, subtract them, that's 20 miles. Let's try 2 hours. 80, which is 40 times 2. 60 times 2, 120. 80 from 120, that's 40. That is the rate at which they're moving apart. In 2 hours, 20 times 2, that'll get you 40. So take a look at how quickly we can do this if we know what to do with the rates, because now all we need to do is say, hey, distance equals rate times time, bud. Throw in the actual rate, which is 20. Let me just mark that off. Times time, which is 4. Everybody, what's 20 times 4? Hardest part of the day. 20 times 4 gives me 80. And there we are. 80 miles, and we are good. Now take a look. We got the same answer in arguably half the time or less, I would say. But there we go. So is anybody here looking at this thinking, wow, not only is this doable, I might dare call this slightly easy. Is anybody looking at this like this is very doable in this sense? I'm glad. Again, this is a common type of question that you can prepare for if you prepare the right way. So with that, I think at this point, we are ready to give practice problems a shot under a timer. I think y'all are ready. Now, I want to give you the respect and give you the opportunity to do this. So with that said, let's go ahead and give these next problems a shot. I'm going to give you multiple choice options, test level timing, 2.5 minutes per question. If you're watching this as a recording, feel free to grab a timer and give yourself 2.5 minutes once you see the problem. But with that, let's give it a shot here. So let me pull up the timer and let's get going. All right, let's give this first multiple choice question a shot. So as always, first thing we're going to do is read the question. Remember, no matter what, the problem can be confusing or it can be easy, but no matter what, you will always make it harder by reading from the beginning. Read the question sentence. So it says here, what is the total distance between them after 3 hours? So there we go. What is the total distance between them after 3 hours? Now, here's the thing. Here's the thing, everybody. Total distance, it could mean add, it could mean subtract. Because if I say that they're going in the same direction and I ask their total distance between them, well, that's still going to be subtraction. So you have got to pay real close attention and not get fooled by a keyword that looks a certain way. Verify. Trust, but verify. But regardless, everybody, we are looking for distance, correct? Sweet. So we'll start there. We'll write down distance as what we're looking for. And now we'll start looking at the information we have. Two objects start at the same location and travel in opposite directions. So immediately as we see that, everybody, they start from the same place and go in opposite directions. What have I repeated quite a few times today in terms of what we'll do? Yeah, opposite directions. Going the opposite way of each other means addition. So now we have verified that, yeah, total distance here, that's going to be addition, because if object A goes this way and object B goes over there, we are going to add B and A together. We'll add them together to get that total distance. But everybody, it's not just the distances that we can add together. What else can we add together? To save time, we can add those rates. Exactly. We can add the distances together at the end, or we can add the rates together in the beginning. Watch and learn. I gotcha. So we have two rates. The first rate for object A, it's 20 miles an hour. The second rate for object B is 15 miles an hour right there. Again, both miles per hour. Because we are working in opposite directions, we can add those rates. So let's get the true rate here. Everybody, what is 20 plus 15? 35, correct. Exactly. So our true rate, the combined rate, is 35 miles per hour. Because again, opposite directions. The time period that we're given, everyone, is what? 3 hours, correct. So this problem doesn't have to be so complicated, right? We have what we need. We're looking for the distance for the combined efforts of A and B. The rates of their combined effort is 35 miles an hour. And then the time that they're both traveling for is 3 hours. So we can go ahead and complete this multiplication here, and we are done. 35 multiplied by 3, we can do that on the side. 5 times 3, that'll give us 15, and we'll carry that 1. 3 times 3, that gives us 9. Carrying the 1 gives us 10. So we have 105. And so there we go, my party people. The total distance that these objects travel together will be 105 miles. If you wanted to add the separate distances at the end, that also works just as well. But there we go. Distance equals 105 miles. Thus, our correct answer is C. There we go. And it looks like a lot of us are feeling pretty good about that. There we are. Now, even if we made a mistake, everybody, who here still understands what that mistake was and what they're supposed to do next time? Right on. And Adesha, to answer your question there, yes, you can do the 20 times 3 because that's 60. Let me write the numbers down for you. 20 miles per hour times 3 is 60. 15 miles per hour times 3 is 45. 45 plus 60, that's going to give us 105. So that still works just as well. Exactly. Yeah, opposite direction, always addition. Same direction, always subtraction. I saw another question of somebody asking, hey, coach, what if we had a gap in the beginning? Yeah, so if that were the case that you're given, then you would just have to account for the gap. So the way that it would look, let me just go ahead and erase a little bit right there. So what would happen is you just want to take the gap into account. So you would take this right here, move it apart a little bit, and you would have that gap be added into the total distance. So if this was, let's say, 50 miles as a gap in the beginning, then you would just add that 50 miles back because the gap would have already been there. Let me know if that makes sense to the person who asked the question. If you start with a gap, not at the same exact position, you would just add the gap into the end. Yeah, so Amelia, yep, that was your question there. Yeah, in that case, you would have added. Now, for anybody who was confused before we continue, let's go ahead and just repeat, or not repeat, but fill in the blank. What operation do we use for opposite directions? When the objects are going in opposite directions, we will correct. We will add. When we're going in opposite directions, we will add. Now, follow-up question, what are we adding? Is it the distances or the rates? Which one are we adding? A lot of us are saying rate, but it can be either, my party people. It can be either one. Again, opposite directions, you're supposed to add. It's either the rate or the distances. If you want to do the rates, you do it in the beginning to get the true rate for an easier formula. Notice how I just have one rate, one time to get one distance. If you went ahead and just did the distances first, you would add those distances at the end. 20 miles per hour times 3 is 60. 15 miles per hour times 3 is 45. Adding those together, 60 and 45, still gives us the same 105 answer. So either way, hopefully that still makes sense. But if we are going in opposite directions, we are adding the distances and rates, whichever way you decide to go. Last pop quiz. When it comes to moving in the same direction, what do we do with those distances and rates? Subtraction, exactly. Subtracting right there. Same direction, subtracting. Opposite directions, we add. So hopefully, again, if you're still confused, we have that written down to at least lean on as we need to. Let's go ahead and try another one out here. We're doing a good job. Let's keep it up. So as always, first things first, we're going to read that question first. So when we read the question first, what we notice is that it says, hey, look, how far apart are they? Instantly, everybody, what key word are we thinking of? What word are we thinking of between distance, rate, and time when we're asking about how far apart something is? What are we thinking? Is it distance, rate, or time that we're thinking of here? Yeah, we're thinking of distance. Remember, we're not trying to think about how we're going to solve this. That's not what I'm asking. I'm asking, do we know what we need to find? How far apart tells us distance, the distance between two things. So yeah, we are looking for distance, how far apart they are. So again, regardless of whether you're confident or confused, that should be the first place for you. Now, number 2, up next, we're going to read the information and just take it in slowly, no rush. We got to make sure that we know what we're going to do before we do it and know the reasons why. 2 runners start from the same location at the same time and run in the same direction. So if we're thinking about 2 runners, we have runner number 1, runner number 2, running in the same direction at the same time. So everybody, let me know. If we're going in the same direction, what operation do we think of? Correct. We are going to be subtracting. Exactly. Because remember, if we're subtracting, we're going to be finding the gap between those endpoints. So with that said, if we wanted to take those rates that we're going to be given here, runner A running at 9 miles an hour, runner B at 7 miles an hour, what do we do with those rates again? The first rate, 9 miles an hour. Second rate, 7 miles per hour. And we will subtract. Exactly. We subtract because, again, opposite directions. Right on. So now we subtract and we get 2 miles an hour. That is our true rate. That is the true rate right there. They're moving apart from each other at a rate of 2 miles an hour. What time are we given here, everybody? What time period are they running for? 5 hours. That's a long time, but that's what the problem says. So they run for 5 hours, so that's the time that we're dealing with. T equals 5. And now we're good. Because if we're trying to find out how far apart they are, we need the rate at which they're moving apart and the time for which they're moving apart at. And there we go. We plug everything in and we are done. Distance equals 2 miles an hour times 5 hours. Everybody, 2 times 5 gives us what? Yeah, and that's going to give us 10. And that's going to give us 10. 10 miles and we are done. If you decided to go the other way and calculate the individual distances, guess what? You still would have been correct. Still would have been correct. That still would have worked, because if you would have done 9 miles an hour times 5 hours, that's 45. 7 miles an hour times 5, that's 35. So everybody, if we did that in that way, that's again 45 miles. That would have been 35 miles. What's the gap between 45 and 35? That's going to be 10. And so either way, with that knowledge, again, it's not about the numbers, everyone. It's not about the numbers. It's about knowing what to do with the numbers. And so whichever strategy you chose, as long as you did it for the right reason, you're in a great spot. So with that, we have one, maybe hopefully 2 more problems to do, depending on how we like this next one out. But my party people, are we ready for another one? Sounds good. Let's go ahead and move it forward to the next one. Let's keep doing our best. That's all I require. Let's go ahead and give this one a shot. Let's go. No matter what, let's give it our best here. Step 1, first of all, everybody can do this regardless of your skill level. What are we being asked to find? What are we looking for, everybody? Correct. We are looking for time right here. What is the time elapsed? Meaning, how much time has gone by? So again, elapsed means, hey, look, how much time has gone by? So with that, everybody, we can all agree, hopefully, that we're looking for time. So we have that going on right there. All right. Now, step 2. Let's understand the information. Remember, it's not just about the numbers, it's about what the numbers mean. So here we go. 2 objects start from the same location and at the same time travel in opposite directions. Okay, again, 2 objects that start at the same place at the same time travel in opposite directions. So everyone, because of that right there, again, same place, starting at the same time, what do you think we might do when presented with the opportunity to interact with the rates or the distances? What do you think we might do? Correct. That means add all day. And I'm glad that a lot of us are using 14, 15, 16 Ds in the word add, because we know it at this point. It's been drilled in, and this is going to help us as we continue practicing. So yes, let's keep reading here just to make sure we got all of our ducks in a row. Here we are. Object A travels at 30 miles an hour. Let me write that down. The rate for object A says 30 miles an hour. The rate for object B is listed at 20. And everybody, what did we say? When we have both of the rates, if we wanted to, we could do what to describe how they're moving together? Correct, we can add. So the true rate, when we consider both objects moving together, the true rate at which they're moving apart is 50 miles per hour. Let me keep that there on the side and bring everything else back here. So we left off here. Let's keep reading. After a certain number of hours, again, the time that we're looking for, after a certain number of hours, the total distance between them is what? 250 miles. So we have our rate being 50 miles an hour, the total distance at the end of it all being 250 miles an hour, or 250 miles, excuse me. But there we are, everybody. If we're trying to find time in the distance rate time formula, we need the relevant rate and the distance, and that's what we have. The distance that they are apart is equal to the rate at which they're moving apart multiplied by the time for which they're moving apart. The distance that they are apart is 250 miles. The rate at which they were moving apart is 50 miles an hour, and that can help us solve for the time for which they're moving apart. And because of that, just like it was said in the chat box, are we working backwards here? We absolutely are, everybody. And that's how we're able to point out what to do in even a problem like this that might be relatively new to us. We can still handle it with grace because we know how to use the distance rate time formula. Everyone, we're working backwards. We'll divide both sides by 50, and there we are. Doing that, we cancel on the right side. leaving us with 250 divided by 50, giving us 5 hours. That is our answer. And booyah, my party people. There we go. We just did, again, a brand new problem, working backwards with multiple objects. But because we were able to understand the information, we were able to make the best decisions to get the answer. This is how it should feel. This is absolutely how it should feel. So, with that said, everybody, today was part 1 of 2. In the next lesson, so if you're watching this live in tomorrow's class, if you're watching this as a recording, there will be another class just like this right after. And what you're going to see in the next class is, well, how do you know what to do when I give you not just multiple objects, but what if I give you multiple events? What do you do then? What if I just give you a random distance, rate, time problem where it doesn't follow anything specific? You actually have to pay attention to the story. So you have to be ready to handle not just this specific type of distance, rate, time problem. You've got to be ready to handle all of those common situations and know what makes the differences between them. My party people, who here is excited to not just get it right, but do it right the entire way through? Right on. And that's what makes me proud to be your coach. So with that said, everybody, this is the end of today's lesson.